All right, we've taken our 4 different pieces of paper. They're 4 different colors, so you can use, again, same colors if you want, 4 different colors. Some people chose 2 and 2. It doesn't matter, okay? I'm letting you use your creativity here. We spaced them out about this far from each other, right here, and then we folded them down so that that's also equal space, and then we crease it. Okay? After we crease it, then we staple it. So it's kind of like a book. Okay? First thing I want you to do as everyone's finishing with the staplers, I want you to think about how could we fold this so that these 2 were not the same color. How can we fold it so the middle 2 were not the same color?
Fold it back.
So if I fold it like back like this, then those would be together. How can we fold it so the middle 2 are not the same color? You only get 1 fold. It's a trick question. No, you can't. If we're only having 1 fold, can you fold it in such a way that that either the outside or the inside is not touching? No. That's a question that doesn't have anything to do with our lesson that I just want you to think about. Okay? So what we're going to do is we're going to label each of these tabs. If you'll notice, anytime we fold this up, there's all this room that we have to take some notes on. Okay? This is going to be our foldable that we'll refer back to several times in the next couple of days. Or even weeks. Okay? So we're going to put a title on it first. Our foldable today is about exponents. You okay so far? Okay. Now some people earlier asked if they could decorate this with like smiley faces and stars and flowers. You go right ahead on your own time. We don't have time for that right now. Okay? And draw any school appropriate pictures on this. Okay? Before we go on with this, though, the next thing you're going to do is turn it on over on the back and write your name. Okay? Write your name. Because when it comes time for like a quiz or a test or something, it's very possible, perhaps, maybe, that you'll be able to use this foldable if it's your own. Hint, hint, hint. Okay. So let's go ahead and fold up this first tab right here. Oh, nope, that's not true. Go ahead and fold it so you have the fold ready, okay? But we've got to write something here. We're going to write something. On mine, it's gray. I know it looks like white to you, but it's really a gray piece of paper, okay? And I want this folded down so I make sure that I can read everything that I write here. Does that make sense? Okay, so we're going to write product of powers. We're gonna know the name of the rule, and it's called product of powers. Okay? This rule of product of powers looks like this. A to the m times a to the n. What do you do with exponents when we're multiplying like bases? Yeah, we add them. A to the m plus n. Now, like I told you a second ago, we're able to fold this up, and you can do that now for real. Okay? And that gives us some room right here for some examples. Okay? Now, here's the thing about this. This is something you already know. You spent quite a bit time on this in Algebra 1. Okay? We've even already talked about some of these rules in Algebra 2. But you know I have to add something onto it, right? So, whoa, ignore that. That's just a smudge. Sorry. x squared times x to the third, what do I do with those exponents? Add them, so I get x to the fifth. That's pretty straightforward, right? So what would you do in a situation like this? I hear your nervous laughter. Do we do anything different? If we're multiplying like bases, what do we do with the exponents? How do I add fractions? Add the numerators. Keep the denominators. Why do people freak out about this problem and not this problem? Because it's a fraction. They have not made friends with the fractions. Okay? So we've done product of powers. You ready for the next rule? Okay. The next rule is called power of powers. Okay? Power of powers looks like this. If I have a to the m power raised to the n power, do you remember what I do with those exponents? Absolutely, I do multiply. A to the m times n. You remember that? Two of you, excellent. Okay, so I'm going to fold up this product of powers sheet so that it gives myself some room for some notes about power of powers. Okay, so if I have x squared raised to the third power, what do I do here?
Multiply.
Which is 6, x to the sixth. Because remember, what's actually happening is x squared to the third power, which means it's x squared times x squared times x squared. And using the rule, which is called product of powers that we just learned, what do we do with the exponents? Add them. 2 plus 2 plus 2. Isn't that x to the sixth? Do you want to have to write this every time, or can we remember this rule? Yeah. Okay. Isn't it kind of a shortcut? Yeah. Now, it's not a trick, right? Tricks aren't very clear about what's happening. We know what's happening. This is really a shortcut, isn't it? So what about this? X to the 1/2 raised to the third. Same thing. Okay, so how do I multiply with a fraction? Wouldn't it just be 1/2 times 3? Would it make you feel better if I did 3 over 1? Oh, okay, so then I just multiply straight across the numerator and then straight across the denominator, right? Yeah, you got this. You ready for the next one? Okay, so this one was power of powers. This one's going to be power of a product. What's implied by product? Or not even implied. What does it mean, product? Multiply, right? So if I have AB raised to the n power, what's happening? What's being raised to the n power? Both of them, right? So A to the n, B to the n. Questions? Okay, so let's fold this one up and take some notes. AB squared. What's being squared? Both of them. So A squared, B squared. You okay with that?
Yeah.
Now I'm going to throw you a curveball, but I'm warning you about it first. Okay? I'm going to have you do 2 exponent rules at the same time. I want you to do power of powers and power of a product. These things are being multiplied, so that's the power of the product, but they're also already being raised to a power, so what am I going to have to do there? Yeah, multiply. So what's it going to end up being? X to the 8th. Yeah, I didn't trick you at all, did I? Good. Let me try one more time. 2xy to the 5th raised to the 3rd power. What's being raised to the third power? So what do I get first? I tricked you this time. Isn't everything being raised to the third power?
Oh, okay.
Even the 2.
Yeah, I get it.
Right?
Eight.
So tell me the most popular wrong answer when people remembered the 2. They tell me 6. Am I saying 2 times 3?
No, you say
2 to the third power, right? So 2 times 2 times 2. And what's that? 8. 8x to the third. You got that part right. Y to the 15th. You got that part right. Okay? Just be careful when there's a whole number here, a constant or something like that. Okay? Because that number is being raised to the power as well. So, AB to the 2/3 power. There's so much impatience in your voice. Seriously, Kingston, we all know how to do this already. I'm sorry. Okay? That says 16a to the 5th, b raised to the 1/2 power. So here's what I have to let you in on. It's not supposed to go until later on in the foldable, okay? But I got to let you in on something or we'll never get the right answer right here, okay? When you have a fractional exponent, the top of the fraction, the numerator, is the power. Well, doesn't that make sense? Because couldn't this be 2 over 1? And the numerator would be the power, okay? The numerator is the power. The denominator is the root. Do you know how to raise something to the 1/2 power? First power, square root. Oh, of course you do. What's the square root of 16? 4. Now I have to do the same kind of multiplication that I did earlier when we talked about power of powers. What's a to the 5th raised to the 1/2? A to the 5 over 2, or a to the 5/2. And then what happens to the b? B to the 1/2. Man, you're suddenly smarter.
Yeah.
Right? Okay, next tab. You ready for the next one? Quotient of powers. What's going to happen in this rule? Division. Very good. A to the m over a to the n. Do you remember? Yes, you do subtract. A to the m minus n.
Yeah, I know how math works.
Good, me too. Let's fold that up so we can get some notes written. That looks really cool on the screen. Kind of looks cool on the paper, but really cool on the screen. Okay, x to the 5th over x to the 3rd. X to the 2nd. 5 minus 3 is 2. Yeah? What about this one, though? You want to do this the easy way or hard way? Easy. What is 8 minus 3? 5. Where did I start with my subtraction? In the denominator. Let's leave the answer there. But if I'm leaving in the denominator, don't I also need a numerator? What is my numerator? Just 1. If I have an x, I still have an exponent, don't I? Okay? Because that's what's here, right? Over 1. We just don't write it because we don't need it. You okay with that? Because otherwise we get into negative exponents and we're not to that tab yet. Okay? So what about x to the 7/3 over x to the 2/3? We are still subtracting. How do you subtract fractions? Subtract the numerators, leave the denominators. Guys, are you seeing the pattern that I'm trying to get you to realize yet? What's the difference between having like whole numbers or integers as exponents and fractions as exponents? Nothing.
Technicality.
Yeah, technicality, that's it. Okay? All the same rules that you already know that apply to exponents also apply to fractional exponents. Are you okay with that? I mean, I know you're not okay with fractions. I'm still working with you on that. But we're going to get there. Next tab is power of a quotient. A over B to the m power equals what? What's being raised to the m power? Both of them. A to the m over B to the m. Oh. You okay with that? Okay. Oh, I don't know what's happening. X over y to the third. What's being raised to the third? Both of them. X to the third, y to the third. Can you do two rules at the same time with division?
Yeah.
A to the sixth over b squared, all being raised to the fourth power. A to the 24th over b to the 8th. Are you getting the idea? Good. No, there's no solving. They're not asking us to solve. They're just asking us to simplify the exponents. Okay? So if I have x over y to the 1/2 power, what's that? X to the 1/2, y to the 1/2. Okay, you ready? Negative. Negative exponents. The rule says a to the negative n equals 1 over a to the n. X to the negative third. Most people are okay with this one because it looks exactly like the rule. X to the negative third really is the same as? Very good. Where people have problems is when it's like this. That doesn't really look like the rule, does it? So you know how sometimes your teachers will tell you silly things to help you remember stuff? Okay, now is one of those times for me. Okay? You see this X? It is so sad. How do you tell that it's so sad? Its exponent is negative. It has just a negative outlook on all of its life. It is in the numerator. Where does it really, really desire to be? In the denominator. When you move it to the denominator, now it's happy. You have helped this exponent with its life. So if it's in the denominator and it's so unhappy, where does it want to go? When you move it to the denominator, or excuse me, when you move it to the numerator, it's happy. Yeah, we can put over 1 if you want to, but is that one of those things that we have to? Okay. So here's where people get messed up with my story. And you have to be very clear about what I said in my story. Okay? Tell me about this negative 2. Is it happy or not? What makes it unhappy? The negative exponent. The negative 2 is fine. Where is it? It's in the numerator. Where does it want to stay? It wants to stay in the numerator. Tell me about the x. It's happy. It wants to stay where it is. Tell me about the y.
It's sad.
Where does, when you put it in the denominator?
It's y to the third.
Yeah. Good.
Yes.
So, as if you needed me to tell you this, what about x to the negative 1/2? Very good. 1 over x to the 1/2. And what about 1 over x to the negative 3/4?
X over 3/4.
X to the 3/4. Whoops. 3/4. Pretend I wrote 3/4 the first time. You okay so far?
Yes.
Okay. Now, we're not going to put a tab on the last page because we're going to use all of it for notes. I'm sorry my name bled through on mine. Hopefully it didn't do that on yours. Okay? First thing we're going to do is this. A to the m over n. I told you this already. I want it written down for us. Okay? A to the m over n. What is the numerator of that exponent? That is the power. And what is the denominator of that? It's the root. So if the denominator is a 2, all you're taking is the square root. If the denominator is 3, what are you taking? The cube root. All stuff you know how to do, right? Okay? So it looks hard. It looks like a fraction. You are smarter. X to the first power equals what? X. Anything to the first power is just itself, right? So here is the hard one. Anything to the 0 power. Okay, before I write this answer down, we're gonna do some area model problems. And we're gonna write it all in the space right here because we need to talk about this for real. Okay? You told me that you knew that anything to the first power is just itself. What is 2 to the first power? It's 2, right? So here's the area model I'm going to draw. And that 2 squares? You okay with that? So what about 2 squared? We know in our head what 2 squared is, right? What is it? 4. So it's really double what I just had, isn't it? So what about 2 to the third? We know in our head that that is 8, right? So isn't that double of what I just had? I'm going to have to draw over my 8. Isn't that double of what I just had? What about 2 to the 4th? I don't have enough room to draw it. If you do, you go right ahead. What does it look like? Double of this, right? So maybe I do have enough room to draw it. I'm not drawing it very well, but use your imagination, my goodness. Isn't that 16? Then I want you to use what you know as far as patterns. Tell me what's happening with the exponents if I start here and go this way. It's decreasing by 1, right? So the next term would be 2 to the 0. Isn't that true? Use what you know about patterns and talk to me about this. Isn't this a square? I know it doesn't look like one. We're using our imagination. Isn't it a square? Isn't this a rectangle? Isn't this a square? Isn't this a rectangle? Shouldn't this be a square? Okay? I want you to use your pattern or your math knowledge about patterns and go down this way. 16, 8, 4, 2, 1. It fits with what my pattern was for the area model too, right? Square, rectangle, square, rectangle, square. What about if we keep going? If I decrease 1 more, what should that be? What shape should it be, first of all? Shouldn't it be half of that? Ignore that. I wasn't trying to draw a flag. How much is that? Isn't that half? Based on the pattern, but think about it. What is 2 to the negative 1 power? Isn't that just 1 over 2? Oh my goodness. What about 2 to this negative 2 power? What shape should that be? A square, and it should be 1/4. Because based on the pattern, it's just half of what came before it. But knowing our rules about negative exponents, shouldn't that be 1 over 2 squared? Well, guess what 2 squared is? 4. Now let's come back and finish our answer right here. Anything to the 0 power is what? 1. It's not 0. Okay? Does that help you understand why it's not 0? Okay? Questions? Is it important for you to keep track of this exponent foldable?
Yes.
I mean, like not really, but if you maybe perhaps want to probably use it, maybe on a quiz or a test perhaps maybe, you might want to have it. And you might want to have yours and not your neighbor's or somebody in another class, yes?
Yes.
Okay? If you want to punch holes in this and put it in your notebook, that's great. If you want to slide it in the front cover of your notebook, that's great as well. You do have some homework problems for tonight. Those are written on the sideboard. You do have some time at the end of this period that you can work on it. On your mark, get set, go.